Hi everyone and welcome back to the multiverse of 100 plus data science project series. In this video, we are creating here an awesome project named Course Recommendation System using Python and natural language processing. First, let's have a look at our demo applications, which one is called Course Recommendation System built by Knowledge Doctor. So you can give here any kind of course name. So let's type it here machine learning. Let's say machine learning. So you can see it also give me the auto suggestions from the list. So if I click here, introduction to machine learning, if I selecting this one as input and click on show recommended course, that you can see it have 6 courses that is recommended by these projects. I mean, this system. So just the six courses that you can select. You can also enroll the course for that. So if I click on this machine learning with big data, and you can see it to redirect to the another page for the Coursera, where you can enroll the course for free. So this is the application that you're going to build from scratch using Python and machine learning. In order to building here the course recommended system, you're going to using here the dataset from the Kaggle. Let's call it Coursera courses dataset 2021. You can also use the dataset for the Udemy as well. Just go on the Kaggle and sign up with your Gmail account and click on here to downloading this Coursera.csv file. We're going to using this one to creating here our recommendation system. So let's go. First, you're going to importing here some of the important and necessary library, and after that, you're going to loading our data sets. So what I can do, I'm going to first import here the pandas spd. Let's say pandas spd import numpy as np. Then I'm going to import here the matplotlib and the seaborn. Let's say matplotlib.py plot as plt. Then I'm going to import here the seaborn as sns, seaborn as sns, and also I'm going to import here the OS if it is needed. That's it. Now after that, I'm going to loading here my data set from my directory. So my data set is already inside my same directory. It's nothing but coursera.csv that you can see after unzipping this file that you downloaded from the Kaggles. Okay, so let's reload it. So what I can do, we can run it here again so that it will removing here the warnings. You can also using here the warnings.ignore. I mean warnings.filter warnings, and you can pass it here the ignore. So let's say data is equal to pd.read_csv, and inside that I'm going to give it here the name. Let's say coursera.csv. So our data is loaded, so you can simply going to show it. So let's say data.head, and then you can see how the data look like. So you have the course name, the university, which university it's from, difficulty level, is it for the beginners or the advanced level for the intermediate levels, and as well as it had the rating. It's nothing but out of 5, it's 4.8. Also you have the course URL so that you can also visit it, and course descriptions it's needed at all, and also the scale, okay, that you can see. Because this is nothing but one NLP types of tasks, so we need to working with the data, I mean textual data, right? So first let's have a look the shape of the data. Let's say data dot shape. So you can see that we have 3522 row and 7 are column. So 7 column is nothing but our features column: course name, university, difficulty level, course rating, course URL, course description, and the skills. So now we can checking here the data.info, is there any NaN value or not, as well as we can see the data type and all other informations. So you can see that we have the column name, we have the not null count, so all of the value are here, we don't have any missing value. But you can also checking this one using this one. Let's say is null dot sum, is null dot sum. Then you can see we don't have any missing value. So if you have the missing value, either we can replace it or we can also delete it. Okay, so now what I can do is simply going to do the value count of the difficulty level, because in the case of difficulty level, how many unique classes we have, so you can calculate them. So what I can do, you can simply going to calculate it. Let's say data of difficulty level. So let's say difficulty level dot value count. So let's say value underscore counts. Okay, so here you can see the beginners is nothing but 1444, and advanced we have the 1005, intermediate is nothing but 837, conversion is 186, and not calibrated is 50. That's mean this data set is basically a building for the beginners level, because you see that we have the 1444. Most of the values are nothing but from the beginner level, as well as it have the advanced level and the intermediate level as well. But most of the value is lies between the uh, lies in the beginner. Okay, so you can also checking here the course rating. So what you can do, so you can simply go to using here data of course rating. Let's say course rating, and you can also do the value count just for ensurity. You can also plotting this out using the matplotlib or cburn. You can do that. Okay, so then you can see it have the 4.7, 4.6, 4.8. So most of the rating is nothing but 4.7 in this data set that we actually use it here. You can also using it here any kind of platform data, just like Udemy. You can do that. We're just actually using the Coursera data sets. So you can see that this is the course rating. Now you can also checking for the university. So let's say data of university. Okay, let's say university. Okay, let's say university dot value count. So you can also checking here the university level as well. Okay, so you have the Coursera project network is the most one. University of Illinois at Urban Campaign, and Johns Hopkins University, University of Michigan, University of Florida Boulder, like that. Okay, GitLab also have. Okay, so those are the university. The best university, I mean, in the case of Coursera, they actually provide the course is Coursera Project Network. Cool. We can also checking here the course name as well. So let's say data of course name. So let's say course name. So course name, you can see the course name. It cannot be the unique because course name may be different. So write a feature, land, screenplay for film or dash dash dash, and business strategy. Then it has the retrieve data using simple table SQL query, and business intelligence and data analysis. Okay, it also have so many types of codes about the data preprocessing, capstone projects, or the business models. Everything it have. Okay, so now what I can do, because you're going to creating here an NLP base of tags. So we are going to using here the content base, or you can also do the popularity base as well. But it's better we can do it for the content base. So in the case of content base, we need the data. So from this data, if I try to checking it here, let's say data dot head. So we have the course name, we have the university, we have the difficulty level, we have the course setting, course URL, course description, and the skills. So from this data, we can taking here the course name, we can taking here the difficulty level, we can taking the course descriptions, we can taking the skills and the course URL. Why? Because we can combine them and try to creating here a new data set which will have the beginner. So if the user is asking any questions about any topics, if it is fall into the beginner, it will recommend he beginner types of courses. Okay, if the user search it based on the skills, so based on this skill it will show here the course name. Okay, so that's why you can taking here the course name, difficulty levels, the course URL, the course description is needed at all, and the skills, and based on that you are going to giving here some kind of recommendation. This is called the feature selections. Okay, so university is not needed. Which university he is from is not a mandatory. If you have a high class profile, as well as your teaching quality is good, no matter about your university. Okay, so we can simply go on here, and you're going to use it in our real-time data that you actually do it. So let's say from the data, we're taking here the course name. We need to give it to here because it has a multiple number of columns. So let's say course name. So it have the course name, then it have the difficulty level. So let's say difficulty level. Then what we have the course description. Let's say course description. You can also using here another one if you are feeling lazy. So you can using here data dot columns. Okay, and then you can simply going to copy it from here. Let's say course descriptions. Okay, you can copy from the course URL as well. Here you go. Okay, you can copy it and you can paste it to here. Simple. Course name, difficulty level, course URL, course descriptions, and the skills. So this is the data. Now you can simply see the data. Let's say data.head. Now your question is ahead in your mind. So why this actually course URL? Because course URL is not important at all. We know that, but it's important. Why? See, because you can see in the in after this http www.coursera.com, it having also some tag. You can see it's also have some tag. That's point number one. And point number two, it we're going to using this one in our applications. So how you combine them, I mean how you actually save this data inside the pickle format to also use to them for recommendations. So that's why URL is needed, so that user can click the recommended courses and it can directly access to the course URL page. So that's why course URL is needed for the user purposes. Okay, now you can simply go into do some kind of actually pre-processing on here. We can replacing here the blank spaces or comma or parentheses like that. So what I can do first, you're going to go inside this course name. So generally in case of course name, it just having some double comma or it having the semicolons like that. Okay, nothing else on here because this is a simple data that it's look like the YouTube titles. Okay, so we can simply replace them. Let's say data of course name. So let's say course name, because it don't have any special character as well, because you cannot put it inside your data in case of the courses. Okay, so let's say data, and you can simply going to give it to here the course name. So you can, let's say course name. So we can simply going to make it a string and you can replace it. Okay, so what you can replace, you can replacing here this blank space to nothing. Okay, so see it having one space, we just removing the space from here if there if have any space on that, because we don't need the space at all. So you can simply going to copy this out, and after that you're going to paste it here 2 times. So now you're going to using here this colon, and also you're going to using here the comma, a double comma. Okay, so if it have the double comma, we can simply going to make it as a single comma like that. Okay, so you can do it. It's nothing but a basic prepossessing, because in the case of title, you don't have anyone. If you are creating here any movie recommendation system, so it may have some emoji, it having may some special characters, so you need to do some uh, pre-processing. So then you can using the npx, sorry, npx, not nfx, or you can also using stoppers, or you can also using some kind of uh, uh, what is called, it's called the special characters. Okay, you can use it here. Okay, you need to removing that, but in here it's not needed at all. You can use it, or either you can also do it from raw. Okay, now you're going to choosing here the data of course descriptions. So let's say course descriptions. So you can copy this out and you're going to paste it to here. Okay, not like that. So you need to give it to here in case of that, and let's say data of course descriptions, and we can using here str.replace, and same thing. So we can simply going to give it here the blank space and with these ones. Now we're going to copy it here, and I'm going to pass it to here the multiple time. Multiple time means 6 time. Okay, why 6 time? Then you can see why. So let's make it comma comma to one single comma, and we also have one semicolons to the space, and also have the underscore, because underscore is also used in these cases. And then you can also use it here the parenthesis, first parenthesis, because most of the time first parenthesis uses. Let's say I'm creating here title transformer from scratch, and I'm going to using here the pythons, or I can also use it here the Hindi or English like that. Okay, so it may be happen in the case of course descriptions. Now you can also replacing here in the case of skill. So in the case of skill, it maybe have just this kind of parenthesis, not at all. Okay, so we can simply going to use it here. Let's say data dot skill, because this is the general knowledge. Because we also creating in the courses, so that's why right? You have the knowledge. So let's say skills. So let's say string dot replace. So and then I am simply going to creating here this one, and then this one, and then you have the data of skills. Hope so. I'm going to launching here some new courses on Udemy and Coursera. Okay, So first I need to buy here one tab, because it's quite important to teach you in the tab, because right now it's not the era of the blackboard or the board. So I need to buy one ipad, or in a tablet, then I can also make the videos. Okay, so course rate should be cheap in cases, because I am also belonging here and poor family and middle class family, so I know that how much is cost or how much is costly for a student to bring in the money from the papa. Okay, no problem, I'll take care of them. So yep, it replaces the data. So you see that anything wrong? We don't see any wrong. Okay, okay, cross check, done. Now you can simply go to checking here data dot head. I'll highlight actually creating here the courses video. I'll try to make it make possible to make it cheap, just like 100 rupee or 50 rupee as a, okay, so that everyone can access. Okay, so course name, it have the difficulty level, it had the course URL. Okay, so now what I can do is simply going to creating here the tags, because in the case of recommended system for the content base, the tags is important. The tag is nothing but the combinations of all of the features. So we can simply going to make it here data of tags. So let's do tags, and then I'm simply going to make it here data of course name, the difficulty levels, the descriptions, and the skills. So we don't need the URL right now, okay, because you're not passing it inside the text. You can also pass it, it's up to you, but you're not going to passing it here. Okay, let's say columns. So we have the course name. So we have the first course name, and then we have the difficulty level, and we have the course descriptions. So then you have the data of course description, then we have the data of skills. Okay, that's it. Now you can simply going to see the data.head. So let's say data.head. So now you can see the data would also have one column called tags, which can actually having all of the course name, the difficulty levels, and the course description and the skills. Okay, now it's combined into tag. We can also see the tag as well. So let's say data dog tag. Let's try to see the first one. I lock 0. Okay, okay, it should be a tags, not tag actually. So you can see the first one, how it look like. Okay, so you can also do some kind of pre-processing on here. You can convert them in the lowercase letter. You can do that. Okay, now we're simply going to creating here a new data frame, which will have the course name, course URL, and the tags. Okay, because it's not needed at all. Descriptions and the skill is not needed at all, because you already have it. Okay, so you just need the course name, the course URL, and the tags. Why? I'll tell you later on. Let's say a new underscore df is equal to data, and inside that we have our course name, and we have the course URL, and then we have the tags. Now, why this course name, course URL, and tags? You know that tags is important because you need to process them, and course name is nothing but for that, so that you can also recommend the users, because you're going to creating the applications. And URL is also the same thing. When it will, our application is recommending here any kind of courses, it will so the user can visit. So that's why the course URLs. Okay, you add it to here, because you need to also save it inside the pickle format. Okay, now we're simply going to replacing here this course name to the course underscore name. It will be better for me for pre-processing, because it's quite large and it's not the way that you can give the column names. So you can using here new underscore df. New underscore df is equal to we can using here uh, the course name. So we can using here the course name. Okay, not like that. Okay, it should be the course name. We can replace it. Okay, we can replace it first. Let's say data of course name. We can also replace them. Let's say str dot replace. If it have any blank space, we replace them. We can do it in here, but it's not needed at all because we are going to do it for the new df. And then uh, sorry, we have the comma. We can replace them with the blank space. And after that, we're simply going to convert our columns, this course name, into the course underscore name. So let's say df uh, new df dot rename. We can simply going to give it the columns, and you have the two columns. One is nothing but the course name. So just convert it to the course name like that. Okay, let's make it in a single quotations. So let's say course underscore name, and then in the case of here, we can give it here the course URL. Should be the course URL. Let's say course. Okay, so it should be the course URL like that. Okay, just convert them, and in the case of in place, so that you can make it true, so that it will be in placing here the actual directions. Okay, actual places. Okay, so renaming here the columns. Now you can see the new df. We have the course name, course URL, and you also have the tags. Okay, now you can see convert it into the lowercase letter as well. Now from here, from these tags, you're simply going to convert them into the lowercase letter, because it having some uppercase letter as well. So it how you actually process them in the machine learning, or in machine learning, or any NLP tasks. So make sure your all of the letters should be in the same way. It can be the upper, it can be the lowers. So let's make it a lower at all. It will be better. So let's say text. So let's say text, and then you can simply go to using the apply method, and you can using the lambda functions, and let's say x of x dot lower. That's it. Okay. Okay, new is not defined. It should be the new underscore df. Now it will apply it inside that. You can see on here. So now if I checking here the new df, then you can see it converting in the lowercase letter. But first it have the uppercase letter. You can see uppercase letter. Now it converted to the lowercase letter. It's fine. You can also check it like this way: new df dot head. Okay, now it's look good. So now we can also check in the shape of that. So let's say a new underscore df dot shape. So you can see the shape is 3522 and comma 3. I mean, it had the three features column. Now we need to converting here this tags into some kind of vectors, because you're going to using here the cosine similarity. So how you actually calculate the cosine similarity, we need to also convert them into the vector, as well as you need to make them product estimate, so that the word is not repeated at all. So what I can do, you can simply going to import it from Scikit-learn dot feature extraction. Let's say feature extraction, feature underscore extraction dot text. You're going to import here the count vectorizers. So you can using here count vector. You can also use it here the tab key from your keyboard. It will give you the auto suggestions. Okay, so let's say creating here an instance of the count vectorizers, and inside there let's give it here the max number of features. So let's say max underscore features. So let's give it here the 5000. You just have the 3522, but make it 5000, and stop words is nothing but English, because we actually using here our English language, okay, as in our data sets. So we use it the English ones, and then we can using here the vectors. So vectors is equal to cb dot feed transform, and inside that we're simply going to give it here our new df of text. I mean, you convert them into some kind of vector. Okay, let's say new text, and then you can make it to the array. So let's say to array, and you can simply going to printing here the vectors. So you can say that vectors of 0th. So now it converted into some kind of numbers. It represent of the vector. This is called the count vectorizers. Now you're going to importing here the NLTK, because you need to also pass it inside the port estimate. Now what is the port estimate actually? Let's say you are beautiful. Let's say beautiful. Let's say your beauty. Okay, your beauty. Okay, just like that. Okay, I'm not going to following here any prepositions, and I'm not going following here any grammatical rules. Just for the ensurety, I mean, just for the understanding purpose. You are beautiful. You are your beauty. Okay, so see here, beautiful and beauty are same. Just having some kind of grammatical issue. Beautiful and the beauty are same. Let's say I'm going to make it. Let's say working, and we having another word called work. So both of the word are same, right? Working and the work, just having some grammatical issue, right? That's mean the word is nothing but same. So what I can do in the case of proto estimator, we're simply going to convert them into two words on a single word. Let's work into the work, okay? So that we don't need to process the word again and again. That's why portal estimator is coming to the pictures. So for that, you're going to import here first NLTK. Let's say import here NLTK. Then from NLTK dot steam dot porter, you're going to import here the portal estimator, and also we're going to creating here an instance of that. So let's create it. Let's say ps equal to porter estimator, and here you go. And then you're going to creating here a functions called steam, which I'm taking one text. Okay, taking one text, and then you're going to iterate to all the value. Let's say for I in text dot speed, and then after that you're simply going to append it inside a list. So we can use it here. Let's say y is equal to list one, and here you go. And then we're simply going to using here y dot append, and inside that you can using here ps dot steam, and you can simply going to pass it here the I, and then you can simply going to return it. Let's say return here uh, return here the this one. Let's say join. We can make it as a y. Okay, so you can now testing this out. Let's say steam, and let's say you are beautiful. Let's say you are beautiful, like that. So you can see you are beauty, like that. Okay, that's been, it will convert it to the one single letter. Let's say you are beauty. Okay, now you can see you are beauty. Just it will convert them into the same letter. Okay, let's say you are working. So it will say, it will making them as a work. Okay, I mean that you can see on that. Okay, this is how the streaming actually work. Now let's apply it to our data. Let's say df of text, and then you can using here new uh, underscore df of text, and you can simply get using the apply method to apply here the functions. Okay, now it will apply to the text, and after that you're going to using the cosine similarity for checking the similarity of the each of the vectors. Okay, so you can import it. Let's say from Scikit-learn dot matrix dot pairwise, we're going to import here the cosine similarity, and after that you're going to creating here an instance of the cosine similarity, and you can simply passing here the vector, and then this is the similarity. Okay, now you have the similarity score. Now you can simply going to recommend courses, not movie, right? So for that you're going to creating here functions called recommend, which I'm taking one course, and after that we can simply going to first taking the index of the course index, because based on the index you also going to take in the course name. So let's say course index is equal to from the new df, and from the new df of the course name is equal to course that is coming. That's mean if the course is available to our data set or available to our databases, it will just stack them and take in the course index. If the course name is not available, it is not taking it also. Okay, that's why here the case conversion is important, because this is nothing but one kind of recommender system with the data. Okay, it not, if you just pass here the pythons or if you pass here the javascript, it's not figure it out, because it's not finding the same name inside the dataset. That's one important thing to notice on here. Okay, also some drawback. Okay, no problem. So then after that, you're going to making the distance. Let's say distance is equal to, you're going to calculate them based on the similarity. From similarity, you can calculate the distance of the each of the vectors. So we can make it here similarity of the course index. Let's say course index. So I mean similarity is called the course index. Based on that, we have the similarity, and then you can simply do calculate the distance based on the course index. Now after that, you can do creating here our course list. Let's say course underscore list. I mean taking the list of that. We are going to taking here 6 or 7 courses. So we can using here list, and we can simply going to enumerate it. We can enumerate the distance, and here we simply going to short them. So let's say short it, and inside that we're going to making here the reverse. So let's make in reverse is equal to true. Okay, it should be the true, and then we can have the key. So key is nothing but our lambda x dot x of 1 to 7. So you can making it like that of 1, and then you can simply going to take it from 1 to 7. So you can see shorted list of enumerate distance that you have, distance we have, then you have the make it reverse so that it will look like the reverse types based on the distance value, and you can simply going to using the lambda functions here to start them. Okay, now we're going to using here for loop for I in course list. Let's say course underscore list, and then we're simply going to taking here the course. Let's say new underscore df dot ilog. We're taking here in the case of 0, and you have the course name. Okay, course underscore name, and this is the course name. Let's say course name, and you have the course url is equal to new underscore df dot ilog, and we have the I of 0th, and you have the course url. Okay, so we have the recommended course. So let's create here a list of that. So let's say recommended course. Okay, let's say recommended courses, and then we can simply going to give it to here. Let's say recommended courses dot append. We can simply going to give it here the name. Name is the course name, and the url is the course url. That's a course url, and then it's simply returning here this recommended course list. Let's say return here the recommended courses. Okay, that's the list we have. Now you can simply go into calling here the functions call recommend. Let's say recommend, and inside that you can give it here a course name. So we can take it from here. Let's try to type here one. I know that it's already available inside that. Let's say business strategy, strategy, business model canvas analysis with micro. Let's say with micro. So we can also take it from here. If I checking this out, new underscore df dot head. This is this one business activity business model canvas analytics with micro. So it out of index because you're checking here the actual course name is as well, so that's why So okay, so you got the arrow line just because of in the case of replacement, I mean for the data preprocessing, you don't want to mistake that we don't give it here any kind of comma. Just to replace them with a blank space. That's the main reasons. So when you getting here any blank space, you just convert them into the comma. So that's the one mistake that I do in the case of same thing on here and same thing on here. So and that's why this output is quite look odd. It's not working. But right now you can see if I give it here any kind of name from this data set that you can see on here. So it will give the suggestions name as well as the URLs, name as well as the URLs, name as well as the URLs that you can see on here. Okay. So you can give it here any kind of thing. Let's say I'm going to give it here retrieve data using single table SQL queries. I don't know if it's working or not, but let's checking this out. It is working or not. So here you go. And now let's see. Yep, it's working. Creating database table with SQL, manipulating data with SQL, creating relational database table using SQLite Studio, retrieve data with multiple table SQL queries, advanced SQL retrieval queries in SQLite Studio, relational database support for data warehouse. Cool. It also have the URL. Now what I need to do, I just need to saving here the data. Okay, so that I mean that the model in the from a pickle so that you can also use it to our applications. Let's say import pickle. Let's import pickle, and then it's simply going to using here pickle.dump, and in here we can first passing here the similarity because it's not it needed at all for calculating the similarity scores, and then inside that we give it here the similarity dot pickle file, and then we can make it wb. You can also store it inside a folder called models. So if I go on here, I can also creating here a folder on here which can store here the models. So let's say models. So you can go on here and you can give it here models uh, inside this models folder. I'm simply going to storing all of them. Save the models. Yeah, models. Now after that, let's say pickle dot dump, and then you can have the new df, and from the new df we first taking here the course name and the course url. So let's say course url, and we just convert that to the dictionary. Let's say to dictionary. Let's give it here a name. Let's say let's make it as the records. Okay, just for records actually, it's nothing else. And you can give it here a name open, and you can give it here inside the models, and it's nothing but my course underscore list dot pickle file, and then you can give it here the mode. The mode is wb mode, and same thing for these cages. So pickle dot dump, and you can also use it here the same thing. So new course name, course url, just going to copy it here, just into removing here the dictionary. Okay, so you can removing here this two dictionary, it's not needed at all, just you can using here this opens. So this dictionary is nothing but just for the records, for saving you're not using it, but you can using here this one courses. Okay, so let's say courses. So in the from wb, now you can simply go into save it. We have the course name and we have the course url, and you can give it to the name. Let's shift enter. Now if I go inside this folder, oh here you go, not here, here you go. So if I go inside that, you can see you have the courses list, you have the courses.pkl, you have the similarity. If I'm checking this courses list.pkl file, I hope so it will opening in the Netron. Okay, I need to update the latest version. Okay, so you can use it in the Netron. Okay, but you can see that it will showing on that. Okay, now it's time to creating here our web applications using the Flux framework. So let's go on here and try to using here this model and try to creating here our applications, which is cool and fine. All right, so now it's time to creating here our web applications. And for this case, I'm going to using here the Flux framework. You can also using the Streamlit as well as the first API. And also you can see we have our code inside our app.py file. You can call it as a server-side code, or you can also call it as an API. Also inside this folder called templates, we're having our designing part in the form of HTML. So here we actually using here the tailwind CSS for the designing purpose. So what I can do first, I'm going to go inside this app.py file and I'm simply running this out, and I'll explain each and every line of code so that you can easily understand that. So how I am actually running this application, it will opening in a port, in a localhost port. I mean this port you can see. So we're going to copy this here, or you can also click to follow the link. It will opening here the application. Let's click on follow link. So it's opening in your default web browser that you can see 127.0.0.1 and 5000 is nothing but the port number. Let's go on the full screen mode so that it look cool. Okay, you can say course recommended system built with love high knowledge structure. So you can give it here any kind of course name. By default, it's shown none. So if I removing that, then you can see example machine learning. So let's say if I type in here Python, let's say Python, and you can see it will also give me some kind of suggestions. So this suggestion is nothing but coming for my course list. So let's say I'm going to selecting here this Python programming essential, and if I click on show recommendation course, then you can see it will recommend me here 6 courses. So I can also click on here, let's say Python data representation. If I click on here, it will directly go to the Coursera web page, and you can access or you can enroll these courses in free of cost. Now let's go on our applications. That's our applications, and this is completely built by using Tailwind CSS. So let's go on the code. So here is the code index.html. So we actually add to the CDN for the Tailwind CSS, and after that we having one body, and inside this body you having one tag, deep tag, and inside this deep tag we having the course recommendation systems and also have the p tag. And this is the important part. So in the next step, we're having one from tag, and inside this from tag, we give it to the method as a post method. And class is nothing but this is an tailwind CSS class MB10, I mean margin bottom 10. And I also add here one labels as well as we having one input box. So in the case of input box, you can see here we adding here a value called selected course. See, we added here a value called selected course in the case of input box, as well as you're going to show here some kind of data in the form of list. That's why actually using here tag called data list. And also you can using here and ginger template, and we're taking these courses from our app.py file. That's been some kind of variable file. I mean variable data is coming from our app.py file. This is why it's called the server side file. And also you're having a button, and high in the user this button, the method is called, and try to taking the input and to process them, and it will give me some kind of recommendations that you can see. If not recommendation is not say there no recommendation found on this, otherwise it will show the recommendations in this kind of case. So it's because you cannot understand this one because we are not expecting here app.py file. So let's go on the app.py file, and after that we're coming here the index.html file again. So let's go inside this app.py file. So first we actually import here Flask. So from Flask, we import the Flask, the random template, and the request. So why random template? Because you need to render the template from our folder called templates. Also, you have the request because it's needed. You're taking the input from the users. Then you have the pickle so that you can also load the model. Then import the NumPy, Pandas, and then you're creating here an applications app equals to Flux underscore name. Then we're creating here and try and accept block. Here we're loading here our model file. So you can see similarity, our courses df, and also courses list in the form of dictionary that you can see. So you have the similarity that you can see. We have the course df that is saved inside our courses.pickle file. You can see our ipmb file as well. And after that, if it is not found, if the file is not found, then we can just give it here some kind of warning, some kind of errors, as well as we also exit from the programs. And then if there are any other exceptions, then we error the loading a model file, maybe some kind of problem or the permission problem, it may be happen. Then after that, we simply going to exit from the code. Otherwise, we're simply going to go inside this courses df and try to taking here the courses name and try to creating here and list of that, because you're going to using here this courses name inside our index.html. If I say that we having the selected course, as well as we having some kind of courses from here, you can see for course in courses, the this courses is actually coming from here that you can see courses name. Okay, so what you see, if I go on the application, you can see if I type here, if I click on here, nothing has happened. If I type here, let's say SQL, see SQL, it will give me auto suggestions. You can see give me auto suggestions. So this list is called the data list, which is coming from the courses. So that's why you start it from here, and as well as the courses UL dictionary, because we also creating here a dictionary, And for the course name, related to the course name, we have also the course URL. And then we're creating here the same functions that we created inside our Jupyter notebook. So we're having, we're first checking that if the course name is given or not. So if the course name is not given or it is not available, we're simply going to returning here a null list. Otherwise, you're taking the index number and distance and recommended course, recommended name, recommended URL, recommended courses, and it's simply returning here this recommended courses. This is the simple same thing that we do inside our course recommendation system while we're creating here the recommendation functions. If I go down, you can see the same thing that you can see on here. Okay, just go down, thoda or we having the functions. It's quite slow because we running this Jupyter notebook inside our BS code. That's why. So you can see same thing. Actually, use it to inside that. Okay. So you're having our recommendation functions. Now you can use it this one. So first, you're going to creating here an initial route and also give it to the method. It's a get method, the post method. Because you are taking, you are going to get the data from the databases. That's why it's better you can use in the post methods. So now you're creating here the index, so you can see the index, so our functions, and then inside this function you're having our recommended courses. This is nothing but this one, and also selected courses is nothing but none. So the course is selected from here our data requested from the course name. Okay, from the course name it will select them. If I go inside this index.html, that you can see in the input text it have a name called course name. Now in the case of selected course, it will select in the course from here, but you need to also passing here two things. One is the course name, you can say on the course name, another one is the recommendations, another one is the selected courses. That's when we passing here three things: selected courses, okay, recommended courses, and the courses name. So this is nothing but pass it to here, and we can directly getting the courses from here, okay, from the data list that you can see. So this courses is coming from here, that you can see courses. You can see courses is starting by the course name. That means you directly passing here the course name in our in our index.html file, and you can directly access to our data list, and so that we can also show here the recommendations. I mean, when the user in a type any, you can see it will give me the recommendations. That means this is already passing to our API, or you can say the server side code. Then we have our recommended courses, and it's simply calling here the functions called recommend, and you're passing here the course that is selected by the users. Okay, so also passing here the courses, recommendation, and the selected courses. And if I go on here, so if I go on here, if the recommendations, I mean, if you have the recommendations, if we have the recommendation, then you can simply go inside that. And if you don't have it, so no recommendation found for these selected courses. Otherwise, we're taking the all of the recommendation from here and to iterate to all the value from here, because it has the 6 value. And then it's simply taking here the recommendation dot name, because it have the recommendation dot name, and we're simply going to showing this out. Simple as like on here that you can see in the case of that. Okay, because it's just easy and you don't need to worry about that. You will get this code in the video descriptions. You can also implementing here this full code inside the Docker. You can do that if you need it. So I'm just simply going to go on the applications, that you can see it's already running. So let's type in here another one. If here the machine learning or not. So I don't know. I don't think that it have the machine learning. Let's see. Machine learning. It don't have anything. Okay. Production machine learning system. Okay. Introduction to machine learning. It have also. Let's click on show recommendations. So introduction to applied machine learning foundation, a case study approach, machine learning with big data, machine learning for data analysis, practical machine learning on AS2O, quite important library, and how Google does machine learning. Okay, that's been our recommendation system is actually really fine. Okay, so that's it for today. Now I hope you enjoy this full tutorial, as well as you also like these projects. So share with your friends and comment down below. If you need any projects, just comment, and so that I also can make in the videos regarding that. So thank you. Namaste.